Evening. Welcome to the premium forecast discussion. It's of course August 15th and it's a Thursday. It's 5 o'clock right now. Wanted to wait a little bit because I've been doing some research on the pattern overall and also wanted to get the latest data
What
on
type
Tropical
of
Storm Aaron.
500 millibar pattern are we developing out here? And we have one that's rather dynamic and rather amplified. We have, especially for this time of year, we have an impressive trough that is just locked in the Aleutian Islands in the Gulf of the Bering Strait, should I say, and a ridge starting to build in the Gulf of Alaska. And then we have another upper level low right off of the west coast, right along British Columbia. We're going to jump to the west into the Atlantic here, specifically the Western Atlantic. And the other factor you want to look for, especially if you're starting to forecast for the winter, is the potential for a negative NAO. It's our favorite little term out there in the world of weather. And basically, there are many different types of negative NAO patterns. There just isn't one. You can have a negative NAO pattern with upper level low around Iceland. You can have a negative NAO pattern with a broad trough and a broad ridge over Greenland. You can have a negative NAO pattern with a very powerful trough over eastern, or say southeastern Canada, and a powerful ridge over Greenland and northeastern Canada. Each one provides a different influence on the weather pattern. So when someone just pulls up an index saying, ooh, negative NAO pattern, there's more to it than that. Cool, comparatively. When we look at the anomalies, you can clearly see neutral around Nino 4 and 3.4. Now, Nino 1 plus 1, which is right about here, 1 plus 2, should I say, which is right around here, it's important, but it's not a driver. That's the key here in discussing El Ninos and La Ninas. What is driving the weather pattern? Okay, just because it's negative 1.2 off of South America doesn't necessarily drive our weather pattern in North America. Location matters once again. Now, this all ties into what I was talking about earlier with convection around the dateline. If you have well above normal water temperatures out here around the dateline in this area right here, that supports rising air. Rising air supports thunderstorms. Thunderstorms supports latent heat energy release, which enhances a trough. That trough enhances the negative EPO pattern, which enhances the ridge downstream, which enhances a trough in North America, specifically Eastern North America. So you see how everything's connected. The question is, to what degree is it connected? And it doesn't necessarily mean that you're going to have a very cold winter in North America, but it does mean that the type of cold polar and Arctic air masses that develop around the Arctic Circle are going to be stronger, more robust, and where they fall, where they drop down, they're going to have a heck of an impact. So I just want to also show the data here is that last year, let's go down here, this is over a year, okay, versus the norm. Last year at this time, we were well below normal in snow cover, well below normal. This year, pretty much near normal. So we're starting out at a near normal base, and that's going to be more supportive of getting our snow growth over North America to above normal levels. And that could be a key factor as we head into the winter, and something we're going to have to watch as we move forward over the next several weeks. If it was the other way around, if we had a roaring El Nino going on right now, or a La Nina right now, those factors would be the dominant driving factors in our weather pattern, and then the stratosphere would be an enhancer. You see, there's a difference between an enhancer and a driver. The stratosphere this summer is a driver. Other years, it's just an enhancer. And the ability of a long-range forecaster is try to determine what's the enhancer and what's the driver of the weather pattern. Here we are at 70 millibars at 90 to 65 north. Again, pretty much the stratosphere has been averaging above normal in the temperatures, right about near normal right now. But the real key is taking a look at the mid levels of the latitudes here, basically where we live. And again, here's our heat wave. Here's our hot weather pattern from mid-June on through July. And here's our change in the weather pattern in mid-July. And here we are in August, where we now have above normal stratospheric temperatures at 70 millibars. So you can see the change in the pattern and the ability to drive those 90, 95, 100 degree temperatures that was well established in this time period that we don't see so much now in this time period as we move through August. And so as we move into the winter months, the most important aspect to really keep an eye on, not so much the mid latitude 65 to 25, it's important, but not a driver, it's an enhancer. This is a driver. If these temperatures end up above normal here, we're going to have a very interesting winter potentially. QBO. This is the stratospheric winds. This is going to be another very important factor to keep an eye on. These QBO indices, these QBO temperatures at 50 millibars, you have another one at 30 millibars, are very important to keep an eye on, especially once they exceed 10. When they exceed 10, they start to have an influence on the ability to transport warm stratospheric air from the tropics into the higher latitudes. When they're positive, it's a lot harder to get done. It can happen, but that westerly component typically doesn't transport all that heat from the tropics into the stratosphere. But when it's negative, which is an easterly wind, that's when it really does a great job of influencing the higher latitudes of the stratosphere via heat transport from the tropics and down. Now, when more ozone breaks down, it causes a cooling. That cooling leads to a cold stratosphere. When you get a cold stratosphere, you end up with hot temperatures. So, the more active the sun is, the more powerful this natural process is on the Earth. So, when you have low solar activity, what typically happens is that ozone is allowed to build up. You increase mass within the stratosphere, which increases interaction, rubbing together of ozone. That increasing ozone leads to warming. That warming leads to what we call stratospheric warming, of course, and cold temperatures at the surface. So you could see a very defined, specific connection from the sun to our weather. Now, that doesn't mean that there's a solar flare that you end up with a thunderstorm 2 days later. Weather doesn't work like that. But it does influence the overall pattern, okay? Especially for a winter. I'll show you. The last time we had a very weak... Now, I'm mentioning this because our sunspot activity compared to what was expected with solar cycle 24 is significantly lower than forecasted. Significantly. And this could be one of the weakest cycles we've seen in 100, maybe even 200 years, if not longer. And with the solar cycle declining now, that means the sun's going to become more quiet. And with it becoming quieter, that means the potential for warming stratospheric influences will increase, and very interesting influences on global temperatures overall will be observed. And it won't be warming, I'll tell you that much. It'll be cooling. How long does this last and to what degree? I don't know. We're talking about solar physics, and solar physics is basically in its infancy. We've come a long way, but there's a lot we don't know. But it's a factor that we really have to consider and we have to watch over the coming months and years ahead. And that is the end of the discussion for tonight. I'm going to take a break, relax, watch some sports, and I just want to thank you for being a premium member. Of course, I'm your meteorologist, Stephen DiMartino. Have a wonderful night. Stay safe out there.